Welcome to this video on significant figures. This is going to be part of a series of 2 videos where we'll talk about how to report significant figures or count them, and in a second video we'll talk about how to do calculations with them. So first we need to talk about what a significant figure is and why it matters. And so to do that, I'd like to return to an example I used in an earlier video on dimensional analysis, where I agreed to pay you for a job and I agreed to pay you $140. And we had agreed in that video that we needed something about units, right? It matters whether I offer to pay you $140 or 140 cents to how you feel about taking that job from me, right? The second thing that we need to know is some idea of the uncertainty or the precision in a value. So imagine that I only have $50 bills in my possession, right? So you finish your job and you were supposed to get $140 for it. What's more likely when I have my $50 on hand, that I'm going to give you 2 50s and give you $100, or that I'm going to give you 3 50s and overpay you, right? When I gave you that value, I ought to have been upfront about the uncertainty or the precision. I had no business telling you that I could pay you $140 when I didn't have the tools on hand, the dollars, to pay you that amount of money. And so this translates to the lab too. You'll be using tools to make measurements, and so in your reports and in your notebooks, you need to be reporting those measurements in a way that's honest about the precision and the strength of those tools. So here's an example. In your handout, you'll see a drawing of a ruler, and it's important to know that the units are centimeters on this ruler. Nothing you haven't seen before, right? That it goes in centimeters and the markings are 1/10 of a centimeter or millimeter markings. And you notice that the end of the object lies somewhere between 2 markings. And so, I could report that this object is 11.6 centimeters long. I could report that it's 11.63 centimeters long, or I could report that it's 11.6267923 centimeters long. 2 of these answers don't make sense, and one of them is honest about the precision of the tool. I eliminate answer A because my tool's a little bit better than that, right? I know that the object crosses after 11.6, so my tool is better than answer A. I eliminate option C because there's no way that my eye is good enough to get that many decimal places on there. However, it is possible for me to estimate that this object is about 11.63 centimeters. And so if I break down that measurement, 11.63 centimeters, first thing I notice is that it has units. The second thing I notice is that up until the last digit are units that I can be, or numbers that I can be sure of, right? The tool knows exactly what those are. And then the last digit is estimated, in this case by my eye. Sometimes on like a balance it'd be estimated by the instrument itself. But again, those are things where the precision of the tool gives out and there has to be an estimate. So when we think about that, we are now learning that significant figures are not just numbers that make us annoying and that we have to count, but now that they have some real meaning to them. So with those things in mind, a good way to think about significant figures is that they're digits, right? They're numbers. What's their purpose? To communicate precision, right? How honest I can be of some measured quantity. I make a measurement in the lab, the digits that I report communicate precision to someone. In other words, they're a way of not looking foolish with your experimental data, not looking like you're more sure or less sure when you're talking with other scientists. The first thing I want to start with is the idea that some things don't have to have significant figures counted. And those are called exact numbers, right? One thing that we can call them is exact numbers. And what they carry is they have an infinite number of sig figs, right? We call them sig figs for short. Why does that matter? I don't have to pay attention to them when I'm doing calculations or reporting. And there are really 2 things that fit into this category. The first one is counting numbers. Right? There's no significant figures in having 12 chickens. I either have 12 or I don't. I counted them physically. There's no significant figures in counting out 6.02 times 10 to the 23rd atoms if we could manage to count out atoms the same way we count out chickens. Those are numbers with infinite sig figs, and I don't have to think about them. 2. Conversion factors. We're assuming that somebody smarter than us and with better tools than us measured these things. And so when I say there's 12 inches in a foot and I make a conversion factor with that, or if I say there's 2.54 centimeters in an inch and I make a conversion factor with that, don't worry about these in calculations. We don't care. Conversion factors have infinite numbers of sig figs, and therefore you can ignore them. For everything else, you're going to have to deal. The first two sig fig rules are really easy, and so we can talk about them together, right? They have to do with digits that are not zero, and as long as they're non-zero, you can count them. Just start at the left and move to the right. So for example, if I had a measurement of 289.6 meters with some sort of instrument, some sort of meter stick that was precise to the 10th of a meter, this is not zero, non-zero, non-zero, non-zero. So I would say that this measurement has 4 sig figs, right? 4 sig figs in that measurement. Where we get tricky is with zeros, and in fact you can kind of think of 3 sub-rules for zeros. Like I said, the zero rules can get kind of ambiguous and kind of complicated, but they're not so bad, right? The first one is if you put a 0 between anything else that's not 0, it's always significant. So for example, if you had a measurement of 13,001 kilogram, what would that have? That would have 1, 2, 3, 4, 5, right? These zeros are between non-zeros. So this measurement has 5 sig figs. The trick is when zeros come at the beginning or the end of a number, right? So in rule B, if a 0 comes after other sig figs and after a decimal point, both of those things have to be true, then they're always significant. So, here's one we've looked at already, 11.63 centimeters. There's no zeros in this, so I count them all, right? This has 4 sig figs. But 11.630 centimeters has 5 sig figs. What this says to me is that these two measurements were taken on 2 different tools, and one tool is better than the other because it has more sig figs. So it's at the end of a number, it's after non-zero digits, and it's after a decimal point, so I count it. Our last rule has to do with what happens when we have zeros at the end of a number. And you notice that kind of scary word ambiguous there. And so what I'm talking about is a number like 5,280 feet. I know that these 3 are significant, right? Those are all just fine because they're not zeros. This one at the end, who knows? And so overall, I don't know how many sig figs there are. Essentially, what you're asking somebody to do is, hey, can you rewrite this in scientific notation for me to give me an idea of how many sig figs there are? So for example, if somebody rewrote that measurement based off of their tool and said 5.280 times 10 to the 3rd feet, you could say that that has 4 sig figs, right? That's just a rule B thing above. But maybe another person who used a different tool says 5.2800 times 10 to the 3rd feet. This one now has 1, 2, 3, 4, 5 sig figs. Totally different number, and we have to treat them differently. So again, you pay attention to the zeros at the end of a number. You say, hey, can you rewrite that for me in scientific notation so that I can tell exactly what's going on? One exception to this I do want you to be aware of that you will see from time to time is if somebody has a decimal point in a measurement where they just put it at the end, what they're doing is they're implying that everything before the decimal point is significant. And so that's the only case, if that decimal point is right at the end, where I would count everything before the decimal point is significant, but everything after that would not be okay. So just be aware of that because sometimes you see it in some of the things you're going to read. So that's how we count sig figs. Now in a future video, go ahead and open that and we'll talk about how to do math with sig figs and be honest with the calculations we do in the lab.